Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge. But it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the fifth largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches.
Venus has exceptionally high temperatures, hot enough to melt lead. It's the hottest planet in our solar system, with a high-pressure environment and super strong winds. The winds there are 50 times faster than the planet's rotation. It's getting stronger over time, and scientists don't know why. But they did find something interesting in the planet's clouds, a potential sign of decaying biological matter. Could there be life then? Not quite, since Venus has a dry, windy atmosphere and doesn't have enough water for life to develop. Rings around other planets are more common than we thought. Saturn's rings are the most famous and spectacular ones. They partially consist of reflective, sparkly water ice, and you can't see anything like that in the rest of our solar system. Jupiter, Uranus, and Neptune have ring systems too, and those most likely consist of dust and rocky particles. And not just planets. Astronomers found out rings were around one asteroid as well. Speaking of rings, why do you think that Earth doesn't have them? Gas giants have rings, while the rocky ones don't. Two theories explain how rings form. They could be the remains from the times when planets were forming, or they could be leftover material of an impact that destroyed an unknown moon, or gravity broke apart this moon of its parent planet. It's not clear why only the gas planets have rings. They formed in the outer area of our solar system, while rocky planets only in its inner circles. May be a good clue. Maybe these inner rocky planets had just better protection from strong impacts that could have formed rings. Also, there are more moons in the outer solar system, and there are more rings there. Another thing may be that bigger planets have a bigger volume, so a ring system can remain stable there. Some theories even say that Earth used to have a ring system. A long time ago, our planet collided with a Mars-sized object, which most likely resulted in a dense ring of particles and debris. But our story was a bit different than the outer planets, and those rings probably combined and formed the Moon. Do we know the shape of the universe? Einstein had a theory of general relativity. It said that the universe could be in one of these three forms: closed like a sphere, open like a saddle, or flat like a piece of paper. Its shape determines whether it's infinite or not, and whether it will expand forever or maybe collapse at some point. The shape of the universe depends on its density and rate of expansion. One of the best ways to determine its shape is to use something called the cosmic microwave background. It's the relic afterglow, something that's left of the Big Bang. Sound waves that were moving through the universe in its early stages produced quite small spatial variations in the temperature of its faint light. The result of these studies showed that the universe probably expands in all directions, which means it's flat. How come our sun is hot while the moon is cold? The sun gives off heat because its core is extremely hot. In there, the pressure is pretty high. The hydrogen turns into helium. That's how the sun creates light and heat. The solar light and heat are enough to light up our days on Earth, as well as support life here, even though the sun is around 93 million miles away from us. The moon is not hot because it doesn't have an atmosphere, so it can't absorb sunlight as our planet does. Its surface gets very hot in the daytime, about 210 degrees Fahrenheit, but since there's no atmosphere, the temperature drops extremely during the night to negative 279 degrees Fahrenheit. The sun is hot, no doubt there, but the space around it is very cold. Heat is the energy objects store inside of it. Temperature is how we measure if something is hot or cold. So when you transfer heat to certain objects, its temperature goes up. Take it away, and the temperature goes down. You can transfer heat in three different ways: convection, conduction, and radiation. Convection works within gases and liquids, and conduction is for solids. The temperature only affects matter. Space doesn't have enough particles. It's nearly a complete vacuum, which means transferring heat is not effective. The only way to do it is through radiation. When the heat coming from the sun falls on an object in the form of radiation, the atoms that make up that object will absorb energy. This energy moves the atoms and makes them produce heat throughout this process. In space, temperatures of the objects stay the same for a long time. Cold objects stay cold, and hot ones stay hot. If you place anything outside of the Earth's atmosphere and expose it to direct sunlight, the sun will heat it to about 250 degrees Fahrenheit. Objects in outer space that surround our planet and don't receive sunlight directly are at 50 degrees Fahrenheit. The temperature is like this because there are molecules that escape our atmosphere, so the sun heats them. We used to think that water was really rare in space, but now we know there's water ice across our entire solar system. For starters, you can usually find water on asteroids and comets. It's also in craters on Mercury and the Moon that are in permanent shadows. On Mars, you'd find ice at its poles, under the surface dust and in frost. It might not be enough to support human colonies up there, but it's still something. Some other bodies in our solar system also contain ice, like the dwarf planet Ceres and one of Saturn's moons. Europa, one of Jupiter's moons, could be one of the most likely candidates we know about that could contain life. It probably has an entire ocean under its frozen and cracked surface. It could have twice as much water as all oceans on our planet together. Titan, the biggest of Saturn's moons, also has a liquid cycle, but it's not water. Its cycle moves materials between the surface and the atmosphere. At first, it sounds like the water cycle we have on Earth. But immense lakes on Titan are filled with ethane and methane. There's a chance they're over a layer of water. Neptune is about 30 times as far from the Sun as we are. Of course, it gets significantly less light and heat than Earth, but it also radiates way more heat than it's generating. There are more things happening in its atmosphere, especially if you compare it to its neighbor, Uranus. Uranus is closer to the Sun, but it still radiates the same amount of heat as Neptune. The winds on Neptune are insanely strong, 1,500 miles per hour. No one still knows why. It could be a gravitational contraction, energy coming from its core, or the Sun. I hope we'll eventually find out. Can you imagine hot ice? It exists just 33 light-years away from us, on one exoplanet. This planet consists of different water elements and they form burning ice. The ice there is solid because of pressure, but the surface temperatures are extreme and go up to 570 degrees Fahrenheit. That's how the water stays super hot and comes off as steam. Picture putting ice in your coffee when you want to heat it up. When you stargaze, it's almost like you're looking into the past. Stars are really far away, and it takes longer for their light to reach our planet. So it's possible some of them have already run out of fuel and aren't alive anymore. The Pillars of Creation are a good example. This is part of a region 7,000 light-years away from us called the Eagle Nebula. These are clouds of gas and dust in the shape of pillars. Scientists first discovered it in 1995, but in reality, a supernova explosion destroyed these pillars that were at least 6,000 years ago. So, the 1995 image shows these pillars from 7,000 years ago. Mars has the biggest volcano in the solar system that we know of so far. It's bigger than the whole state of Hawaii, and 100 times larger than the biggest volcano on Earth. The red planet seems so quiet, but once upon a time, large volcanoes dominated its surface. Volcanoes on the red planet can probably grow so big because gravity there is a lot weaker than down on Earth. Also, the crust on our planet is moving all the time, and the Martian crust probably stays still.
Joseph Walker is about to have an historic flight, but he does not know of it yet. He smiles at his chase pilot, showing the OK sign, and closes the cockpit of his steel friend, the newest unpowered rocket plane, X-15. It's placed under the wing of a B-52 bomber. They take off and go up to 45,000 feet. Joseph is calm and full of joy because he has been getting ready for this moment his whole life. He trusts his steel-winged friend like no other. The bomber drops the X-15. The rockets fire up, and with a fantastic thrust, Joe flies steeply toward the edge of space. He knows his dream of making the first ever suborbital plane flight will soon come true. Joe adjusts the controls to intensify the rocket energy. In contrast to the usual blue sky plane view, the beautiful curved planet Earth view and a black horizon is a visual privilege only a few people can have. Joseph Walker's reaction shows he is experiencing zero gravity. "Welcome to space," the pilot says quietly. "We did it, guys." The Walker surname has always automatically propelled him to action. He just had to go forward, strive for higher results, and not stop. As a teenager, he loved to run, arms outstretched at the sides. He imagined that his legs lifted off the ground suddenly, and he felt himself flying, soaring up both as a man and an airplane. When he worked as a test pilot, he used to fly over city lights at dusk. They assembled themselves into gigantic mosaics below and reminded him of faraway stars he wanted to reach. His dream of becoming an astronaut and getting the astronaut wings, which he considered a great honor, was born at that time. On his way to his dream, Joe studied a lot and got a bachelor's degree in physics. He also had extensive test experience in the early X-series aircraft and 27 flights in rocket aircraft after joining the NACA, which stands for the National Advisory Committee for Aeronautics, in Dryden in 1951. He combined the experience with sound engineering judgment. What drives a test pilot to risk his life every day? Courage, duty, devotion, passion? All of it. Joe was a talented test pilot and would not have traded jobs with anyone, but he had always aimed higher. So he became the right person for the X-15 spaceflight program when he was invited to be its chief pilot. The whole team, including the engineers and all the 12 test pilots, had to prove that they could design an airplane that would fly and survive at hypersonic speeds. Before, there was only a theory about hypersonic flight and subscale wind tunnel testing. That's why there were many questions like, will they be able to prove it? Will they manage to design an airplane that will be stable and controllable at hypersonic speeds? Could they possibly create a structure that would survive the high heating rates associated with hypersonic speeds? And, more importantly, could a pilot survive and function adequately in this high-energy environment? When the X-15 launches from the bomber's wing, it first goes into a free fall for several seconds, and only after that the rockets can be ignited. So there was a considerable risk of a rocket failure too. The team also had to design an airplane that would be controllable outside the atmosphere and could successfully re-enter it at high speed and steep entry angles. If the X-15 took the wrong angle, the plane would be destroyed. So could they prove all of this? To regularly tempt fate is a real job of any test pilot. Joseph knew the anatomy of his winged friend as much as his own because his life depended on it. The X-15 looked like a big propellant tank with a cockpit. It was 50 feet long, 20 feet wide, and 13 feet high. But the propellant tanks took up approximately 25 of those 50 feet. The X-15 weighed 15,000 pounds without propellants and 33,000 pounds loaded with them. The propellants consisted of liquid oxygen and anhydrous ammonia. To fly at the hypersonic speed of Mach 6 or 4,000 miles per hour, one must have an airplane that will survive temperatures as high as 1,200 degrees Fahrenheit. That's why the X-15 was built of steel Iconal X, a tough, high-strength nickel-steel alloy. Only 3 aircraft were built. The X-15 was by far the fastest plane existing at that time. It could fly at a speed of up to 7 times the speed of sound, which is 4,520 miles per hour. Joseph Walker could fly to the edge of space and land again within 12 minutes. The plane was powered by a liquid rocket engine Reaction Motors XLR-99, which delivered a powerful thrust of 57,000 pounds. During Walker's first X-15 flight, he was unaware of how much power the rocket motors had, and he was slammed into the pilot seat yelling, "Oh wow!" The enormous ejection seat weighed 270 pounds. It had 2 large stabilizing fins deployed after ejection and 2 large telescopic booms that extended for seat stabilization. The aircraft had a conventional wing, although small, with only a 22-foot span and roughly 200 square feet of area. The aircraft's tail was unusual, with 2 canted horizontal and 2 vertical surfaces. These tail surfaces resembled the feathers on an arrow. They served the same purpose, keeping the aircraft stable and pointed in the right direction. The upper and lower vertical tail surfaces were pretty large and thick compared to conventional airplanes. They were wedge-shaped in cross-section with a sharp edge in front and a broad base at the rear. This provided additional stability and prevented the aircraft from swapping ends at extremely high speeds. The airflow sensor on the airplane's nose determined the airflow direction and impact pressure. This sensor was referred to as the ball nose. It was servo-driven to align with the airflow affecting the aircraft's nose. From this, the engineers obtained the angle of attack, the side slip inclination, and the impact pressure of the air flowing over the aircraft. The ball nose was cooled with liquid nitrogen to prevent it from melting during high-speed flight. Walker sometimes liked to playfully bet with his fellow test pilots who would be the first to lift the rocket plane above the Kármán line, the internationally accepted boundary of 62 miles. On August 22, 1963, during Flight 91, Joseph Walker sets a world record of the highest altitude of 67.08 miles reached by an unpowered plane X-15. The X-15 is hoisted up to the pylon on the B-52 wing. The hoists are located in the X-15 servicing, fueling, and mating areas. All pre-flight checks are completed. Takeoff. The X-15 is the first aircraft to utilize an inertial platform and a computer. Standard barometric instruments are almost useless in the X-15. Joseph has them on the instrument panel, but he only uses them during landing because they don't work at high altitudes or outside the atmosphere. For a sizable portion of the flight, he uses inertial data for control and guidance. Launch. The X-15 drops away from the bomber and gets into a free fall for several seconds. Then the rockets start by burning within 85 seconds, producing extreme power. Joseph pulls the plane up at a steep climb-out angle to start forming a long parabola and comes out of the atmosphere. The pilot has good visibility since the windows are next to his head. One very unusual thing about the visibility out of the X-15's windows is that the pilot cannot see any part of the airplane. He cannot see the nose, he cannot see the wings. Nothing. Typically, pilots use the nose and the wings in an aircraft for attitude reference. In the X-15, all Joseph has for a reference is the window frame, which is very disorienting on the one hand. But on the bright side, such a panoramic view is just right to enjoy the splendid horizon, a boundary between Earth and space. Joseph thinks how quiet it is here, like nowhere else. Mission completed. Joseph completes a perfect parabola and re-enters the atmosphere successfully. The X-15 is like a tough old bird that pops and bangs as it accelerates above extreme speed. But it all hangs together and gets Joseph Walker back home. He is ready to start a glide, landing from space. The X-15 has some outstanding features that significantly enhance the safety of landing. It has highly effective speed brakes, which are essential in an unpowered aircraft to adjust energy and ensure a pilot gets back to the ground safely. The more effective they are, the more precise the control of the power and the more accurate the landing. It's hard to imagine, but the pilot lands the X-15 only about 11 minutes and 8 seconds after its launch, having gone through the distance of 337 miles. Joseph Walker makes history as the first civilian test pilot flying to space by a rocket plane twice. Despite all the risks of the X-15 program, the courageous test pilots pushed the very limits of their piloting skills and physical health to master groundbreaking experimental technology. The program's overall success helped develop the Space Shuttle program and paved the way for NASA to continue to the moon decades later. Joseph Walker got a lot of awards and the cherished astronaut wings, but only many years later. The Lunar Landing Research Vehicle, used to develop piloting and operational techniques for lunar landings, was trusted to be piloted by Joseph, and the famous moon crater Walker was named in his honor.